So section 5.3, properties of logarithms. The first property, we're going to use the change of the base. Let a and b and x are real positive numbers. A not equal 1, b not equal 1. Log to the base a to the x is going to be log to the base b to the x over log to the base b to the a. That means here is the new base. There's going to be x on the top, and a from base is going to be to a number. Or you can use the common log, which is log to the base 10 is going to be log to the x. So it's going to be log to the x over log to the a. Or you can use the natural log. So it's going to be ln to the x over ln to the a. Now, we have another properties, which is the product property. Every time when you have log a v times u times v, is going to be log a to the u plus log a to the v. Quotient, if you have division, so it's going to be log a u minus log v. Power property, if you have log to the base a, u to the n, you're just going to move the n in the front. So it's going to be n log to the base a to the u. The same thing here, you can use the ln or you can use the common log instead of log to the base. So if you use the ln, it's going to be, the product property is going to be ln u times v is going to be ln u plus ln v. The quotient property, ln u over v, is going to be ln u minus ln v. The power property is going to be ln u to the power n. You're going to move the n here, so it's going to be n ln to the u. So let's start with example 4. We're going to rewrite the logarithm as a ratio of common logarithm and natural logarithms. That means we're going to use the change of the base. So for example 4, we're going to write down as a ratio common. So we have log to the base 9, 71. Log to the base 9 to the 71. This one we can write down as a log to the 71 divided by log to the 9. Or you can write down as ln as a natural logarithm. So you're going to say ln to 71 over ln to the 9. That's it for this example as a ratio between these two logs. So here you're going to say fraction. You're going to type, I think there is another function, the ln function here. Yes, ln to the 71. This is the log. So the first thing, I'm going to type the log here. Log to the 71 over, you have to close it, yes, over log to the 9. And here, we put two parentheses. And here's going to be also fraction, ln to the 71 over ln to the 9. This is for the first question. Example 5 is going to be exactly the same thing, but it's going to be log to the base 1/3 to the 4. So this one is going to be log to the 4 over log to the 1/3. Or you can say it's ln to the 4 over ln to the 1/3. So both is going to be right. Which one you're going to use? And here they ask you to write down both. So here's going to be log to the 4 And here is going to be log to the 1/3, 1/3. And the natural log is going to be ln 4, and here is going to be ln to the 1/3. 1/3. Let's go to example 6. On example 6, let's check what they ask you. They ask you to use the change of base theorem. Example 6, evaluate using change of base theorem. Keep loading. Evaluate using the change of base theorem. So log 3 to the 14. Log 3 to the 14. So it's going to be log to the 14 over log 3. I think they just ask you to write down like this, or we have to evaluate. That means we're going to plug in the calculator log to the 14. The next step, we have to round our result to 3 decimal places. So log to the 13, you see, I'm going to use the common log to the 14 is equal 1.14612. I'm going to stop until here, over log to the 3, which is equal 0.47712. Then divide this one divided by this one. The result is going to be 2.402. Check here, there is 1. I'm going to round this one, so it's going to be, this is the result for this example, is going to be 2.402. 2.402. So that's the result for this one. I know, I think this is exactly the same thing. But now let's see what they ask you. Use the properties of logarithm. Now they ask you to use the change of base theorem. We're going to use the properties of logarithm to find the result in terms of log 2 base 3 to the 2 and log base 3 to the 7. So if you look to the 14, this is example 7, it's the same result. It's the same example here. But now you have to use what they ask you to use. We have to use the properties. So I'm going to say this one equal log to the base 3 2 times 7. Because 14 is 2 times 7. This is not point. This is multiplication. 2 times 7. Now, by using the product rule, is going to be log to the base 3 to the 2 plus log to the base 3 to the 7. Now this one is going to be equal. They're telling you here, log to the base 3 to the 2 equal. That's it, I think, because we don't have to simplify it. We just have to write down in the term of 2 and 7, and that's the result. So we're going to stop until here because we don't know how much it's going to be, and you don't have to write down the result. They just ask you to write down in the term of 2 and 7. So we're going to say this is log. I can type the base here. I have to choose the functions, log to the base 3 to number 2 plus log to the base also 3 to the 7. We got it right. Now we're going to do the same thing for example 8. For example 8, they're telling you use the properties. So example 8, we have log to the base 2 5/7. So it's the quotient property. That's mean the division. So by using the division is going to be log to the base 2 to the 5 minus log to the base 2 to the 7. That's it. That's the solution for this one. I'm just using the second property, the division. So it's going to be log to the base 2 to the 5. Make sure the 5 under the parentheses minus log to the base also 2 to the 7. Close the parentheses. So that's it for this example. Example 9, they ask you use the properties of logarithm to write down the logarithm in terms of log to the 5 to the base 5 to 3 and log to the base 5 to the 7. So let's check that. First of all, I have division here, the quotient. I'm going to use the quotient property. So it's going to be log to the base 5 to the 3 minus log to the base 5 to the 4, 9. And if you look to this number 49, I need to write down the result in term of 3 and 7. So this is 49. So I can write down 49 as a 7 squared. That means this one is going to be log to the base 5 to the 3 minus log to the base 5, 49, sorry, 7 squared. Then 7 squared. Then by using the power property, I can move the square here, the exponent in the front. That means it's going to be log to the base 5 to the 3 minus 2 log to the base 5 to the 7. Now, our terms is a 3 and 7. This is just a number. So this is the right solution. So we're going to say this is log to the base 5 to number 3. Close the parentheses, minus 2 log to the base 5 to number 7. Close the parentheses. So example 10, we're going to do exactly the same thing. Use the properties of logarithm to write down the logarithm in terms of log 5 to the base 5, 3 and log to the base 5, 7. So now we're going to check 63. 63 is 9 times 7. So I'm going to write down this one is equal log to the base 5, 9 times 7, which is mean equal log to the base 5 to the 9 plus, because the product rule, so it's going to be plus or product property, log to the base 5 to the 7. Then I need to write down in the terms of 3 and 7. This is okay, but now I need to simplify this one. So the 9 is equal 3 squared. That's mean I can write down this as log to the base 5, 3 squared plus log to the base 5 to the 7. Then I using the power property, I can move the exponents here to the front. So this one is going to be 2 log to the base 5 to the 3 plus log to the base 5 to the 7. Now our solution is written in the term of log to the base 5 to the 3 and log to the base 5 to the 7. So it's going to be 2 log to the base 5, and here is a 3. Close the parentheses, a plus log to the base 5 to the 7. Close the parentheses. That's it for this example. Let's move on to example 11. We're going to do the same thing, and we need to write down in the term of 3 and 5. So example 11, we have log to the base 7, and we have 21 over 5. 21 over 5. So the first thing, I'm going to use the quotient property. I'm going to say it's equal to the log to the base 7 to the 21 minus log to the base 7 to the 5. Then next step, this is okay. I have this term here, but I need to simplify the 21, the term of 21. So I'm going to say the 21 is 3 times 7. 3 times 7. That's the only option. Okay. So that means this one is going to be log to the base 7. And here is 3 times 7 minus log to the base 7 to the 5. The next step, this is the product rule. I'm going to use the product property here, or the product rule. So this one is going to be log to the base 7 to the 3 plus log to the base 7 to the 7 minus log to the base 7 to the 5. If you look to this part here, we have rule that says if you have log to the base A to the A equal 1. That means everything here equal 1. In this case, I'm going to write down the 1 first, and I think if you write down the 1 in the middle is going to be right. It doesn't affect anything. So it's up to you how you can write it down. You can write down as log to the base 7 to the 3 plus 1 minus log to the 7 to the 5. Or you can write down as a 1 plus log to the 7 to the base 7, 3 minus log to the base 7 to the 5. Both way is going to be right. This is example 11. Let's type it. We got it right. So let's move to example 12. On example 12, find the exact value. It's only without using calculator. So how to find the exact value without using calculator? So log, that means you have to show the steps. So log to the base 5, 1 over 125. So I can write down this as a log to the base 5, 1 over 125, which is 5 times 5 times 5 equal 125. So I can write down as a 5 cubed. So I'm going to say here's 5 cubed. There is one of the exponent rule that says if you have 1 over a number with positive exponents, you can write down as a number with negative exponents. That means this one is going to be log to the base 5, 5 to the negative 3. Now, remember there is a rule that says if you have log to the base a to the a with x, the result is going to be just an x. Here is the x, which is negative 3. Or there is another way. You can solve it by using this rule, or you can solve it by using the power property. That means I can move the exponents here. So it's going to be negative 3 log to the base 5 to the 5. Now, I already know if I have log to the base and the base equal the number is going to be equal 1. That means everything here is going to be equal 1. So in this case, it's going to be negative 3 times 1, and the result is going to be negative 3. So we got 2 methods to find one. Both is going to be right. So this is the exact, which is negative 3. So example 13, let's check how we're going to solve this one. So the first thing, there's a rule that says one of the exponents rule. It says if you have x to the n and like this with the radical. So it's going to be x to the n over m. So we're going to convert from the radical form to the rational form. Radical form to rational form by using this rule. So here is the ln. This one is going to be e to the 2 over 3. Now, next step, by using the power property, I can move the exponents is going to be here. So it's going to be 2 over 3 ln and e. I already know that ln e is equal 1. So everything here is equal 1. That means it's going to be 2 over 3 times 1, and it's going to be 2 over 3. That's it for this example 13. We're just going to type here 2 divided by 3. You're going to do exactly the same thing with example 14. With example 14, we have ln e to the power 6 plus ln e to the power 9. So this one is going to be, I'm going to move the exponents here, is going to be 6 ln e plus. Move the 9 here, so it's going to be 9 ln e. Ln times e equal 1. So this one is equal 1, and this one equal 1. So it's going to be 6 times 1 plus 9 times 1, which is equal 6 plus 9, which is equal 15. So the result for example 14 is going to be 15. For example 15, we have log to the base b 2 over 5. They ask you, we need to find the approximation solution. But if you look here, there's no base. But I can use these information. I have log to the base b to the 2 and log to the base b to the 3 equal 0.5 and log to the base b to the 5. So what I'm going to do, I can use the change of base. I'm going to say this one is equal to the log to the 2 over log to the 5. as a common base, which is the 10. So this one is going to be equal. Log to the base 2 equals 0.3562. So 0.3562 divide by log to the base 5 is going to be 0.8271. Now, our result, we have to divide these two numbers. So it's going to be 0.3562 divided by 0.8271. The result is going to be, and round your result to 4 decimal places. So it's going to be 0.4306 430 and 6 is going to be 7. That means the result for this example is going to be 0.4307. That's it for this example. I can't use the common base here. Why? Because they're telling you log to the base b equal 2. To the base b to the 2 equal this number, and log to the base b to the 5 equal this number. So I'm not going to use the change of base theorem. That's why I got it wrong. So what I'm going to do, I'm going to use the other property, which is the quotient property. So I'm going to say this one is equal log to the base b to the 2 minus log to the base b to the 5, which is equal 0.3562 minus 0.8271, and the result is going to be negative 0.4709. So this is the result. That's why we got it on here. Negative 0.4709. Let's check. Example 15. That's it, we got it right. You're gonna do exactly the same thing with example 16. Log to the base to the 20. Wait a minute, let's do this one. Because now 20 is just a number. We can't use 2, 3, and 5. So what we're going to do, we're going to use the product property. That's mean, for example, 20, it's 16. It's log to the base b to the 20. Is going to be equal log to the base b, I'm going to say 4 times 5, or 2 times 10. 2 times 10, yes, we can use this one, because 2 times 10 is 20. I can say it's 2 times 5 which is the same thing. Let's say 4 times 5. 4 times 5, that's a 20. Then I can say 4, it's log to the base b to the 4 plus log to the base b to the 5. Then I can simplify the 4. It's 2 squared. So this one is going to be log to the base b 2 squared plus log to the base b to the 5. Then next step, what I'm going to do, I'm going to move the exponents here by using the power property. So it's going to be 2 log to the base b to the 2 plus log to the base b to the 5. In this case, it's going to be 2 times log to the base b to the 2 is going to be 0.563. 3562. Yes, 35. Plus log to the base b to the 5 is 0.8271. So that's mean is going to be 2 times 0.3562 plus 0.8271. And the result is going to be 1.5395 for decimal places. So we're just going to type here 1.5395. 5395. So 1.5395. That's it for this example. Example 17, you can use the properties of logarithm sum of difference. So we're just gonna write down this. We're not gonna find the exact or approximate solution. So we have ln to the 3x. Sorry, ln to the 9x, example 17. 9x. You can use the properties of natural log, which is 9 times x. So this one is equal ln 9 plus ln x. That's it. That's the solution. We can simplify it because we don't know how much the value of x. So we can say this is ln to the 9, close the parentheses, plus ln to the x. The same thing with example 18. Example 18, it's log to the base 9 x cubed. Log to the base 9 x cubed. This one is equal. I'm gonna move the cubed here. So it's going to be 3 log to the base 9 to the x. That's it. We can simplify it. So we're gonna say it's a 3 log to the base 9 to the x. You got it right. Example 19, we have ln xy to the exponent y, to the exponent 9. So the first thing, I have exponents. I'm going to use the power rule or power property. So it's going to be 9 ln to the xy. Ln to the xy is mean ln x times y. So what we're going to do here is going to be equal 9, open parentheses. It's going to be ln x plus ln y. That means this one is going to be 9 ln x plus 9 ln y. That's it for this example. Because we're going to use the product property here on the xy, then you have to distribute the 9. So here is going to be 9 ln x plus 9 ln y. Close the parentheses. That's it for this example. We got it right. So now with the example 20, we're going to do the same thing. But now we're going to use the quotient property. So for example 20, we have log to the base log to the base 8 w to the power 4 over v. So the first thing, this one is going to be use the quotient property, log to the base 8 w to the power 4 minus log to the base 8 to the v. Then I have exponents here. I'm going to move the exponents in the front by using the power property. So it's going to be 4 log to the base 8 to the w minus log to the base 8 to the v. So that's it for this example. So we're going to type here 4 base to the log 8 to the w close minus log to the base 8 to the v. That's it for this example. Let's move to example 21. Example 21, we have ln x, y, z to the power 5. So it's multiplication. So this one is going to be equal. I'm going to use the product property. So it's going to be ln x plus ln y plus ln z to the power 5. Then on this part only, I'm going to use the power property. So I'm going to move the ln, the power, the exponents in the front. So it's going to be ln x plus ln y plus 5 ln z. That's it for this example. So here is going to be ln x plus ln y and plus 5 ln z. Example 22, the same thing. So example 22, we're going to do the same thing. So here's the variables. I'm going to use the product property. So this one is going to be equal log to the base 4, 17 plus log to the base 4 to the b to the power 6 plus log to the base 4 to the c. And then I have power here. So move the power on the front. So it's going to be log to the base 4 to the 17 plus 6 log to the base 4 to the b plus log to the base 4 to the c. So that's it for this example. So it's going to be log to the base 4 to the 17 plus log to the base 4 to the b plus log to the base 4 to the c. Close the parentheses. Let's check we got it right. Let's work on example 23. Ln to the x squared minus 1 over x to the power 7. And they're telling you x greater than 1. So the first thing, I'm going to use the quotient property. So this one is going to be ln to the x squared minus 1 minus ln to the x to the power 7. Now, next step, if you look to this one, just x squared minus 1, we can factor this one by using difference between two squares. So it's going to be ln x plus 1 and x minus 1 minus ln x to the 7. Then this parenthesis times this parenthesis, so I can use the product property. So it's going to be ln x plus 1 plus ln x minus 1 minus ln the same thing, because I have x to the power 7 here. So I can move the exponents in the front by using the power property. So minus 7 ln to the x. So that's it for this example. So we can type ln to the x plus 7, x plus 1, ln to the x plus 1, close the parentheses, plus ln, to the x minus 1, close the parentheses, and minus 7 ln to the x. That's it for this example. Next one, 24. We're going to do exactly the same thing. So you have to know how to use the properties, because the rest of these examples is going to be the same process. So example 24, the first thing I have division here. That means I can use the quotient property. So this one is going to be equal log to the base 8 x cubed minus log to the base 8 y cubed z to the power 4. Then if you look to this side, it's multiplication. So we can say this is log, and be careful here, to the base 8 x cubed minus log to the base 8 to the y cubed plus log to the base 8 to the z to the power 4, because the minus is going to be distributed here. So then it's going to be log to the base 8 x cubed minus log to the base 8 y cubed minus log to the base 8 z to the power 4. Then I'm going to use the power property by move the exponents here and here and here. So it's going to be 3 log to the base 8 x cubed, x minus 3 log to the base 8 to the y minus 4 log to the base 8 to the z. That's it for this example. Just gonna type it. Got it right. So 25. Let's move to example 25. So 25 is the fifth root. So 25, it's ln to the fifth root of yz over x squared. So this one is going to be equal. I'm gonna just write this one again by using converting the radical. You have m here and x n, so it's gonna be x to the rational exponents, which is n over m. So that's what I'm going to do here. The exponent is 1 over 5. So it's going to be ln to the yz to the x squared to the exponent 1 over 5. Then by using the power property, you're going to move the exponents to the front. So 1 over 5 ln yz over x squared. And this one is going to be equal. Now 1 over 5, just keep it outside. Open a bracket. Ln yz over x squared is going to be ln yz minus ln x squared. Then I'm going to use the product property here because it's multiplication, and the power property here. So 1 over 5 here is going to be ln y plus ln z minus, move the exponent here, minus 2 ln x. Then the last step, I'm going to distribute the 1 over 5 here. So it's going to be ln y over 5 plus ln z over 5 minus 2 ln x over 5. That's it for this example. So let's type it here. So we're going to say ln y over 5 plus, you have to put the parentheses, another fraction. I'm going to say ln z over 5 minus 2 ln x over 5. You got it right. So for example 26, we're going to do the opposite thing. We're going to start from this step and we're going to go back to the single log or single ln. So here is the last step and we're going to go back. So if I have number in the front, the log, that means this number is an exponent. So I'm going to bring it back as an exponent. So it's going to be log to the base 8 to the 3x minus log to the base 8 x to the power 8. You can write down the 8 here, or on the x is going to be the same thing. Now next step, I have minus between two log, so it's going to be division. So it's going to be log to the base 8 and 3x divided by that x, yes, divide by x to the power 8. So we wrote this one as a single log. And I don't think that you have to simplify x with x8. Just type it like this. So I did mistakes here. The exponent here is 7. When I bring it back, so here is going to be 7. And here is going to be 7. So be careful. So I change this one to 7. Number 27, we'll do the same process. So example 27, there's a number here. That means this is an exponent. And there's a number here, the same thing. So this one is going to be equal ln to the 5 cubed minus ln to the z minus 8 to the power 4. Then there is minus between 2 ln, so it's going to be the natural log ln to the 5 cubed divided by z minus 8 to the power 4. That's it. You can simplify it. You can't put z to the power 4 because this is a parentheses you have to distribute, but you don't have to make it that much harder. Just type like this. Z minus 8 to the power 4. So here's going to be ln. Here's parentheses. I'm going to put division here on the top. 5 cubed. 5 cubed. And on the bottom here, I think we have to simplify 5 cubed, which is 125, because it's a number. So we can say this is ln 125, which is 5 times 5 times 5, over z minus 8 to the power 4. So we have to type here. Let's keep going. If you multiply this one, should be right. And another 2 parentheses to write down z minus 8 to the power 4. Let's check what they're going to tell us. Yes, it's right. And if you want to type it as a 125, it's going to be right too. Number 28, we have 5 brackets, 4 ln to the x minus ln parentheses x plus 3 minus another ln parentheses x minus 3. So now let's check how we're gonna write down this as a single log or single ln. So here is the 5 bracket 4 ln to the x. 4 ln to the x, 4 is an exponent. So I'm going to write down right away as a ln to the x to the power 4. I'm going to take a minus as a common between these two ln. So it's going to be ln x plus 3 plus ln x minus 3. Let's keep going. Here is going to be equal. Distribute the 5. So it's going to be 5 ln x to the power 4 minus 5 here ln plus ln. So it's going to be ln x plus 3 times x minus 3. Then here's going to be, this is another exponent. So it's going to be ln x to the 4 times 5 minus, here's going to be, put down the 5 here. So it's going to be ln x plus 3, x minus 3 to the power 5. Here is going to be ln to the x to the power 20 minus, there is multiplication between these two. So it's going to be, if you multiply, it's going to be ln to the x minus 9, sorry, x squared minus 9. And here is to the power 5. Minus between two ln, so it's going to be ln x to the 20 over x squared minus 9 to the power 5. So we write down this as a single ln. Let's check that. We got it right. That's it for section 5.3.